The broadcast is now starting. All attendees are in listen-only mode.
Test audio. Hello, good morning, good afternoon, and good evening to all the teams. I'm here. I'm Luca Gianzini, Market Development Manager, Inks, Paints and Coating for Europe. I'm the today's speaker for Sasol, and I will present you the webinar. So Fischer-Tropsch boxes for wood coating in solvent base and water base. Maybe someone know already me because I presented the first webinar, the powder coating one. And we will go through today with around 55 minutes to see the performance of our box in water-based system and in solvent-based system. I want to underline three things. First things, this section will be recorded. And in the next 2 weeks, we will upload in our Sasol page on YouTube this recording webinar like the other one. This is the third webinar for Sasol in the inks, paints and coating area. Second things important, I will try to reply to all your questions. Of course, you need to press the button. By GoToWebinar, there is a button where you can ask your personal question about the presentation and about the product itself. My team and the Inks, Paints and Global Inks, Paints and Coating Global team will take care to reply to your question in the next 2 weeks. Let's go. I will move myself now and let's go through the presentation. So agenda, there will be an introduction of Sasol and on our Fischer-Tropsch box. Second, we will see some slide on the first part of the webinar. Then Janine Snyder, my colleagues, presented some months ago on the water-based wood coating, so on our Fischer-Tropsch box in water-based wood coating. Then we will go through in the Fischer-Tropsch box emulsion in water-based wood coating, a summary of the results. Then last but not least, the Fischer-Tropsch box in solvent-borne system, summary and a little bit of Q&A. Some words of Sasol. Sasol is a global integrated chemicals and energy company. They are working around 31,000 people globally, and we are different technology, and so let's say we have different facility around the world. We safely and sustainability source, produce and market a range of high-value product streams in 31 countries, creating superior value for our customers, shareholders, and other stakeholders. One of our technology is the Fischer-Tropsch, as you know. I will show in this slide an overview, a fast, smart overview of the wax that can be used in a wood coating area. So we have the paraffin waxes, micro waxes, P waxes branched, P waxed linear, and Fischer-Tropsch R waxes. Of course, we market the first, the second, and the third one because and the Fischer-Tropsch, the last one, because this is what Sasol today produce and offer in this market. Paraffin waxes has, of course, a low viscosity, molecular mass around 400-700, medium crystallinity, and a melting point range that go from 40 to 70. Then we have micro waxes and paraffin waxes we produce in our facility in Hamburg. Then we have micro waxes, viscosity medium, molecular mass from 600 to 800, crystallinity low, and melting point from 55 to 90 degrees. Then we have the polyethylene waxes, branched, viscosity high, molecular mass around 1,500, 3,000 Daltons, crystallinity medium, and melting point in a range from 100 to 120. Then we have the polyethylene waxes linear with a viscosity medium, molecular mass 3,000, 10,000, crystallinity high, and a melting point that go in a range in the market from 125 to 135 degrees. Then our Fischer-Tropsch waxes, or in general Fischer-Tropsch waxes, with a viscosity very low, molecular mass 750 to 1,500, crystallinity very high, are synthetic waxes, and a melting point that go in a range from 80 to 150. So more or less, this is a fast overview of the waxes that there are, the most common waxes or most common possibility that you can find in a wood area. We can proceed with an overview of the Fischer-Tropsch waxes that Sasol offer. Today we have three base waxes. We have three base waxes. We have Sasol Wax C105, Sasol Wax H1, and Sasol Wax C80. Sasol Wax C105 has a congealing point from 102 to 108, and high molecular mass, high level of crystallinity, low viscosity, and a great performance at higher temperature. Then we have the famous Sasol Wax H1, congealing point from 96 to 100 degrees, high level of crystallinity, low viscosity, yields good high temperature properties, and good heat stability. Then we have Sasol Wax C80, congealing point from 80 to 85, medium molecular mass, narrow carbon distribution, we can consider as a narrow cut, and low viscosity. This is an overview of our base waxes, and from these base waxes we are going to produce our micronized waxes. This is an overview of our portfolio of micronized waxes. As you know, Sasol Wax has two technologies to produce the micronization. We can produce spherical morphology, so by a spray tower. We have the Sasol Wax Spray 30 for that, and the Sasol Wax Spray 105, the two spherical option. congealing point follow the base wax, and we can jump to the particle size distribution. The D50 that is important in my area in the expensive coating is from 5 to 7. Then we have the irregular morphology or grounded. We have our jet mills that we can produce here in Hamburg, different kind of micronization product. You can see here we have the Sasol Wax Spray 30G and GEF. So G is with higher D50, and GF with the extra fine, means with a D50 from 4 to 5. The melting, as I told you before, follow the base wax. And we have different kind of possibility from the M version with a D50 from 9 to 11, the L version with a D50 from 11 to 13, and of course the extra fine and the normal micronized one. Then third option are the modified Fischer-Tropsch waxes. We have two possibilities. We have the Sasol Wax Aqua 30 GEF and Sasol Wax Aqua 30 G. GF and G, they follow the micronization extra fine with, so means 4 to 5, and normal grounded from 6 to 8. This is an overview of our micronized wax and also of our possibility in the expense and coating. Now I want to show you a summary of the first webinar. So let's go into the wood coating. So as you know, wood coating market covers stains, varnish, clear coats, top coats, and paints, different possibility for indoor and outdoor application. Major market segment for wood coatings are furniture, joinery, flooring, and decking. We can find in the market three different possibility on water-based or waterborne, solvent-borne, and UV curable coatings. So the waxes in this case are important because can provide you abrasion resistance. So means preventing scuffing, prevent scratching and marring. Then for slippery, so anti-slip properties, increase or decrease the coefficient of friction. For matting or texturing, for water repellency, to reduce dirt pickup or for dirt pickup resistance, mostly for outdoor application, and for anti-blocking. These are mostly the purpose in the market to choose the right wax. Then we have different kind of wax that we can find in the market. Fischer-Tropsch to achieve this purpose. Fischer-Tropsch waxes, Carnauba waxes, paraffin waxes, polyethylene, linear or branched, and amide waxes. The typical wax amount in the total system go from in a range from 0.5 to 3%. I hope that I cover in a short way more or less something of this word. Let's go on the wax side. So why and how we can choose a wax? So what is the criteria? Mostly we have 4 particular points where we can touch to choose the right wax. The melting point of the wax that should be lower to follow the curing temperature. And also the melting point is connected to the melt of the wax inside to permit the migration to the surface, to permit the recrystallization, to form a continuous film. So it's important in this case also the transition phase of the wax from solid to liquid when you have a curing application. Or an oven curing application. Then we go to the particle size, of course the particle size distribution. When I mentioned to you particle size for me means D50, and particle size distribution, of course you have all the distribution. Important point are the D50 and D90, and sometimes the D99. Particle size should be equal to permit a slightly larger than, to permit a thickness of the coating layer. Then the micronized waxes will follow the ball bearing mechanism. Of course, our waxes will improve slip properties and abrasion resistance. If we play with the hardness, we can modify the scratch resistance, the abrasion resistance, and the slippery. Then the emulsification is important. Also, the emulsification permits the bluing, follow the bluing mechanism, and also the emulsification of the wax can permit a better behavior in a water system or in other kind of system. And also they permit and they work as water resistance, block resistance, gloss retention are important, of course, for this point. These are the results that we show in the second webinar. So where you can see with that Sasol Wax Aqua 30G and Sasol Wax Aqua 30GF, so the two modified Fischer-Tropsch wax, grounded and extra grounded, they obtain very good results in a water-based system. So for appearance, for scratch resistance, for block resistance, they achieve the best results, and also for slippery. In competition with other Sasol Wax waxes, like what I showed before to you, for example, Sasol Wax Spray 30G or Sasol Wax Spray 105G, these two kind of modified waxes, they achieve the best results. And also in with other possible competitor product like HDPE wax, or competitor chemistry like HDPE wax, like modified PE wax, or even against a blend of PTFE and polyethylene wax. So it's important to show you that these two products are promising, and I'm excited to show you these results. We can continue. So mostly this is an overview of our two waxes. So as I mentioned to you, Sasol Wax Aqua 30G is a fine micronized powder. The congealing point is 95, around 95. Penetration at 25 degrees is below 1.5. Color is off-white. Acid value from 3 to 7. Saponification value is from 11 to 17. Molecular weight is around 1030. And as I mentioned before to you, D50 is 7 and D90 14 maximum. Then we have the other option, the extra fine. Again, is a micronized extra fine wax. Congealing point 9504. Penetration below 1.5 of white. Acid value like the Aqua 30G, and what change, of course, is the D50 and D90 is an extra fine wax, so the particle size distribution is different. We have from 4 to 5 the D50 and from 8 to 10 the D90. So very promising product, and I hope that you will request a sample for possible used in a water-based solution. And I suggest you, if you didn't see, to see on our website the before webinar, where you can see also in which kind of formulation we tested this product and all the specific performance of these two products. We can continue. So as I mentioned before, the waxes are used in a water-based solution for scratch resistance, or block resistance, for slip resistance. Again, Sasol Wax Aqua 30G and Aqua 30GF achieve the best performance and they show very high hardness, so means good scratch resistance. They show excellent slip properties. They show improve in your system the block resistance, and also a lower melting point respect a possible competition. So means energy saving when they melting, so in a cooling temperature system. So I suggest you to choose the right wax for your future formulation. This was an overview of the first webinar, and now we start the first part of this webinar, the third webinar, so water-based waxes emulsion in waterborne wood coating. I'm excited to show you this test because we enter in the market with, we present a new product in the market, and I want to show the performance of this new product. So we tested we tested the waxes at 1.5% and 3.5% based on solid polymer in kitchen cabinet and in furniture top coat formulation. This is important to underline to you that we choose these two specific formulations, so kitchen cabinet and furniture top coat, and is not doesn't mean that we use 1.5 or 3.5% of wax, but means that we use 1.5 and 3.5% of the total solid polymer with inside wax. This is the water-based wood coating formulation. I don't want to read through the line. You can have time when I will send to you separately in the next 2 weeks the presentation. So here the overview on what we tested for this specific for the water-based formulation. So we have Hydrovax 5080. That is a Fischer-Tropsch emulsion wax that melt. The melting temperature of the wax inside the emulsion is 88. The pH of the emulsion is 9.2. Is based on a non-ionic anionic system, and the percentage of solid is 35%. Then we have Hydrovax Experimental 004. This is an experimental product, so means that is a lab product, but is important to show you the performance also of this product for a future possible production. Is based as well on Fischer-Tropsch, is a Fischer-Tropsch waxes, so is a Fischer-Tropsch emulsion. The melting point of the wax is around 112, pH 9.5. Based as well on a non-ionic anionic system, and percentage of solid is 35. Then we have the new commercial product, the Hydrovax 5028, is a modified Fischer-Tropsch emulsion. Melting point, I'm excited to show you this product that promising a lot of performance. Melting point of the wax is 107. pH is 7, and is a non-ionic product, percentage of solid 35%. Then we have a free competitor product where we will show you the performance against together with our wax or with our emulsion. We have the competitor sample 1 is a modified wax emulsion, melting point of the wax 90, pH 9.5. Ionic character is a non-ionic product and has typically 35% of solid. Competitor sample 2 is an HTP emulsion, melting point of the wax 135, 141, pH 8.5, non-ionic, and percentage of solid 35%. Then we have finally modified PE emulsion, melting point of the wax 120, 125, pH 4, non-ionic, and percentage of solid 37%. So this is an overview of the wax on the emulsion that we use to test and to achieve these results. Wax incorporation, or some words about that. All waxes that we evaluated processed without any problem, exceeding an 8 Engbang grind riding. All sample resulted in a pH value of approximately 8. Hydrovax 5028 and modified PE emulsion, both at 3.5% loading, resulted in a lower pH value. Viscosity of the sample were found to be similar for all the emulsion. Only the PE emulsion resulted in an increase in sample viscosity, and we found an highest viscosity being given by 3.5% of loading level. I will leave to you the wood panel processing, and I will go through the test, the first result. So the first result show the scratch resistant with the grain. So we use a maple panel tested after 28 days after the application, using a needle stylus with a scrape adhesion tester with the grain. So you can see here the control, so means without wax, give a result of 24 in the test. You need to read the test, so means the highest value is better. So we can see that Hydrovax 5028 at 1.5% achieve the best results, and the overquote respect the other product and respect also the competition. Then we have will follow Hydrovax 5080 and Hydrovax experimental 004. So in this test we show that for scratch resistant with the grain, Hydrovax 5028 at 1.5% wax plus polymer achieve the best results, promising. Then this was the scratch resistant with the grain. We can pass now with the scratch resistant across the grain. Always, like before, maple panels tested 20 days after the application, using a needle stylus with a scrape adhesion tested across the grain. The control, so means without wax, was 45, and we have we have Hydrovax 5080 and Hydrovax experimental 004 that they achieve the best results at 1.5% and follow Hydrovax 5028. Best result of Hydrovax experimental 004 and Hydrovax 5080 respect the other Sasol wax emulsion, and respect also the competition. The test was conducted using, as I told you before, a needle stylus, so with a range from 0 to 1, and a progressive loading rate of 0.212 over 60 millimeters. So in scratch resistance across the grain, so before with the grain and across the grains, we show that our wax emulsion achieve a very good results. Then we go to I go to show you the mar resistance, or back on fingers. So we have also here is a block resistant test with fingernail. You need to read the test so the highest value means better. So we have Hydrovax 5080, so the 88 melting emulsion, that achieve the best results of the test at 1.5%. Then follow Hydrovax experimental 004 and Hydrovax 5028. Also so Hydrovax 5080 achieved the best results, respect the other emulsion, and also respect the competition. Same results we got with 3.5% for 5080, a little bit better from experimental 004 and for Hydrovax 5028. Follow the modified PE emulsion at the end. So the control was, so means without wax emulsion, achieved 2.5, and you can see here that we have a huge higher performance if we use Hydrovax 5080 or Hydrovax 5028. So with a fingernail test. Then we have the mar resistance dig in. Again, for a block resistant tested with fingernail, same like before. You need to read the test with, so means the highest value is better. We have a control Novax that achieve 1 in the performance, so means without wax. We have Hydrovax 5080 that achieve a similar result like Hydrovax Experimental 004 at 1.5%, and then follow Hydrovax 5028. Then we have so best result respect all Sasol Vax emulsion, Hydrovax 5080 and Hydrovax Experimental 004. And if we increase at 3.5%, we can see that increase the performance of mar resistance dig-in. Again, we have the overquote of Hydrovax 5080 and Hydrovax Experimental 004, and follow the Hydrovax 5028. At 3.5%, we have a similar performance of a modified P emulsion. Then we can continue. This is the slippery. We tested the slippery with a maple panels, tested 28 days after application using a slip angle test. So lowest value means more slippery. So if you want less slippery, you need to see this test opposite, so the highest value. If you want more slippery, you need to see the lower value. The control, so means without emulsion, wax emulsion, achieved 25 in the maple test, and we have Hydrovax 5080 again that achieve very good performance of slippery, and then follow Hydrovax Experimental 004 at Hydrovax 5028 at 1.5%. And with Hydrovax 5080 achieved the best result of all Sasol wax emulsion and also against the competition. If we increase at 3.5%, we have practically only more slippery for Hydrovax Experimental 004, the high crystallinity wax emulsion, and we have an opposite result with Hydrovax 5028. So in this case, if you are going to make a wood coating not on floor but on different other surface, and you don't need slippery but you need the opposite, Hydrovax 1528 is the best solution at 3.5%. We can continue. We have now the gloss retention or the matting, or in this case, I remove what is better, what is worse, because it depends on your application. You need only to read this test on the highest value means that we are going to maintain the gloss or to increase the gloss. The lowest value means that we are going on the matting side. So means that the emulsion give matting. In this case, you can see that the Hydrovax 5080 at 1.5% decrease the gloss. So if you need to read this graph as a matting agent, and with all the performance that I showed before to you on the slippery, anti-scratching, and mar resistance. So means that Hydrovax 5080, differently from the other two Hydrovax, so the Experimental 004 and the Hydrovax 5028, can give you the right performance plus the purpose to be used as a matting agent. You can see that Hydrovax 50-2080 opposite can give you right performance but maintain the same gloss like without wax, where we have a control of 86. Then we have the block resistance. As you know, the block resistance is the union of the static force and the kinetic force. Lower are the static force and the kinetic force, and better is the block resistance. We have, you need to read this graph with the less value is better. We have Hydrovax 5080 that achieve at 1.5% the best value on static force, the best value or similar value like Hydrovax 5028, and both they achieve a very good performance respect a competition of like HDP emulsion or modified wax emulsion or the other modified PE emulsion with a different melting. And this is important to show you because if you need a good block resistance, this graph show you the performance of our FT emulsion. Then we go on the kinetic force. Kinetic force, again, you need to read this graph with that means the lowest value is better. We have the best result was achieved from Hydrovax 5028 at 1.5%, then follow Hydrovax 5080 and Hydrovax Experimental 004. Again, you can see that also on the kinetic force, we have better performance respect the competition and at 1.5%. At 3.5%, the best result, we have the best results with Hydrovax 5080 and then follow the other FT emulsion. Control without wax was 1454, you can see here. So means that the performance of our emulsion decrease a lot the block resistance, so very good performance. In conclusion, based on this water-based wood coating study on emulsion, I can suggest you that Hydrovax 5028, the new modified Fischer-Tropsch emulsion, provide to you very high hardness, so means scratch resistance, good mar resistance, good slip properties. This is important, excellent gloss maintenance and good block resistance. So I suggest you to test and to ask a sample to our ink paints and coating teams. Then on the other side, you can see here that Hydrovax 5080, so the emulsion based on a melting of 88, achieve as well very high hardness, so scratch resistance, good mar resistance, good slip properties, excellent matting. In this case, I underline this point because respect Hydrovax 5028, where there is a maintenance of the gloss. In this case, we have a matting with similar properties and then good block resistance. So again, I will invite you to ask a sample to our team or to me. Without problem, we can provide to you in a fast way. After the first water-based section, we go into the solvent-based section, so solid Fischer-Tropsch waxed in solvent-borne wood coating. Here you can see we tested 7 products, so Aqua 30 GEF, our modified Fischer-Tropsch wax with a melting of 107, then and a particle size distribution of D55 and D98, our spray 30G Fischer-Tropsch wax with a melting 107, not modified. Then we have with a D50 of 7 and D90 14. Then we have our Sasol wax spray 30 GEF, the Fischer-Tropsch wax 107, 5 to 8. And then for competitor sample, so we have as first one the modified PE wax with a melting of 115. Similar particle size, so D58 and D90 15. Sample 2, a modified PE, a blend of a modified PE and PTFE or polytetrafluoroethylene with a melting of the wax 125, particle size 7.9. Sample 3, a modified HTP wax. 140 the melting, and 6 to 14 the D50 and D90. And then at the end, sample 4, a blend of normal PE wax and polytetrafluoroethylene, a melting of the wax 102 to diversify the sample 2, and particle size D56 and D14, D9014. So again, I want to underline you that we tested with 2 different percentage, as you can see, 3.5% and 7%. And these 3.5 and 7% are based on the solid wax on solid polymer. So it's not 3.5% of wax, pure wax, or 7% of wax, but is a combination. We sprayed the coating on the maple as both a sealer and top coat with 4 or 5 range of wet mills. And then we cure with a cycle of 30 minutes at 25 degrees. We can start, some words on the wax incorporation. So we create a pre-dispersion. So each wax, we create an isobutanol pre-dispersion. The target was 37%. Each wax appear processable for a pre-dispersing in isobutanol without problem. The most troublesome, let's say, problem that we saw was with HTP wax, modified HTP wax. For this wax, we couldn't achieve more than 26.66% of wax, or let's say on wax in polymer content. The target was 37%. And Sasol Wax Aqua 30 GEF, the PE polytetrafluoroethylene blend, and the micronized modified PE wax resulted in the lowest viscosity dispersion, like 740 centipoise, 760 centipoise, and 840 centipoise. The wax pre-dispersion based on Sasol Wax Aqua 30 GEF was the only pourable composition, and the Sasol waxes all processed at higher solid content, so means 37% without problem. We can continue. I think that you can spend time on this slide with the clear catalyzed lacquer formulation that we used to proceed on this test. And as I mentioned before, we created this pre-dispersion in isobutanol at 37%, and then we used a clear catalyzed lacquer to proceed for the test. Again, it's important, the 3.5% and the 7% are based on solid wax on solid polymer. We can proceed. This is the first results that we achieve. So the exudation, you need to read the test with the lower value is the best. What the exudation is an important topic in wood coating, and you can see here that Aqua 30 GEF achieve the best results respect the other Sasol wax, but also achieve the best result respect the competition, and the value respect the control. So that is without wax was 15.6. I mean, we achieve below 6, and is a great value if you compare with the competition. So, and is even lower if we increase the content of wax. So with 7% of polymer, wax in polymer, we achieve below 2. This, I think, that is very important for you, because exudation is a problem in the wood coating, and our Sasol Wax Aqua 30 GF, so the modified wax, achieve a very good result. Not only this product, but also our Spray 30 GEF achieve a good results if you don't want to use a modified Fischer-Tropsch. and follow spray 30G, not the extra fine. We can continue, so best Aqua 30GF and spray 30GF. We have then second test that we have done is the scratch resistance. We tested with a maple panel, tested after 28 days after the application, using a needle stylus with a scrape adhesion tester. You need to read these results with the highest value is the best for scratch resistance. So we have Aqua 30 GEF that achieve a great result, respect the other wax and respect the control. So control was 65 and we achieve around 90 with 3.5%. So better respect all the Sasol wax product in this test and also against the competition. Then we have a more aligned result with 7%, where we have Aqua 30GF similar to spray 30G and similar to spray 30GEF, and follow the competitor product. So scratch resistance, again, I want to underline you that Aqua 30GF achieve great performance. We can continue. We have the slip. So slippery test, more slip means the lowest value again. We have the control without wax is 23. So you see that Aqua 30GF at 3.5% achieve a great result, around 20. And follow the other wax, so spray 30G and spray 30GEF. So Aqua 30G is the only one below the control, so very good slippery in a solvent-based system. So promising wax extra fine modified. And so I suggest you to test this product in a wood coating application. Then we have the blocking or block resistant was tested after a minimum of 7 days at room temperature, and you need to read the test with so the lowest result is better. Control without wax was 1074, and we have in this case we have a similar result. Aqua 30GF, we have spray 30G that at 3.5% achieve the best results, and follow Aqua 30GF and spray 30GF. So in this case, if you need only a great block resistance plus other performance, of course, but is very important for you, the block resistance, the suggestion is spray 30G at 3.5% or at 7%, and you have even lower a better block resistance. But these results show to you that Aqua 30GF in any case is aligned with the performance and also is aligned with the competitor performance. Stain resistance, so you need to read this test with the best result is the highest. So surface, we tested on Lenetta. We tested different stain, so around 25 different stain, and we decided to combine with an average. The control without wax is you need to read as 74, and you can see here that for Aqua 30GF achieve a good results respect the other Sasol wax. And also align with the competition, so align with a modified PE blend with polytetrafluoroethylene. So great results again for Aqua 30GF. Then follow spray 30G and spray 30GF. So if for you is important the stain resistance, the suggestion is the modified Fischer-Tropsch wax, of course. Then Again, the test on the gloss. I remove also in this case what is best, what is better, what is not good, because it's based on the performance that you want to achieve. If it's important for you the gloss, you need to read this test. The highest value is better. If it's important the matting, you need to read the low opposite, so the lowest value is better. In this test, you can see, I mean, in any case, you know that if you use a wax inside the system, normally the wax, they decrease the gloss, so they give a little bit of matting. In this case, you can see that Aqua 30 GF or Spray 30 GF or Spray 30 G, they are aligned with the competition, and they are aligned with what exists in the market. So not worse and not worse respect to the competition. So you need to summarize all the results that again, if you consider all the good results that I showed to you till now, you see also that also on the gloss performance we are not less the competition. So important to underline. We can continue. So this is a summary of what I showed to you now. So we have in a solvent-based system based on the formulation with the that I showed to you in the slide before, that I suggest to you to study if it's similar to what you are using or not. The suggestion is that for exudation, scratch resistance, and of course slippery and stain resistance, Sasol Wax Aqua 30 GEF achieve the best performance, respect Sasol Wax, and also respect the competition. So means respect the modified PE Wax and respect the blend with a modified PE Wax or with modified PE Wax and PTFE, or with a simple PE and PTFE. Then, if it's important for you the block resistance, we have our Sasol Wax Spray 30G, where you have in any case a good exudation, a good scratch resistance, a little bit of slippery, a great block resistance, and also a stain resistance. So this is an overview of our portfolio based on the test that we, based on this test that we have done in solvent-borne wood coating. And I suggest to you again, like with the water-based system, with the webinar that Gianni Snyder showed to you, and also based on the webinar that the first part on the emulsion, I suggest to you to ask a sample. And for Sasol Wax Aqua 30 GF for solvent-based system, Aqua 30 GEF and G if you are managing a water-based system, and Hydrovax 5028 and Hydrovax 5080, that are the two new emulsion, Fischer-Tropsch emulsion for water-based system. I think that this is again a summary, so means that at the end, in a solvent-based system, if you need scratch, block, and slip resistance and are important for you, and you want to, let's say, not lose so much of glossy, Sasol Wax Aqua 30 GF is the best solution of Sasol Wax portfolio, and also against a competitor product based on polyethylene, and can give to you very high hardness, so scratch resistance, less exudation, that is important, excellent slip properties, so mar resistance, can improve block resistance, and also is a good stain resistance. So important for you choose the right sample. I think that we finish now exactly. I will show myself again. I saw that there were a lot of participants and you request a lot of questions. I will read you now some questions, and as I underlined at the beginning, Sasol will take care in the next 2 weeks to reply to all your questions by myself or by our team. So first question, there was a question regarding if the products are global or we can sell and propose globally. Yes, all the products that I show to you now are present globally. There are dedicated teams based in Europe, in USA, and in Asia, and that can support you with a sample request. So no problem on this side. Then second question, if these products are only for wood coating. If not, please explain all the other application. Not, of course, if you remember, we present now free webinar, and I want to underline you is a little bit of promotion of the next webinar, the fourth one, where we will go to show you the performance of our Fischer-Tropsch boxes in inks. Definitely all these products that I show to you are not only for wood coating, but also for deco paint, are for inks, for powder coating. Of course, you need to follow the Sasol Wax suggestion based on the webinar results or based on our team, dedicated team that can suggest to you the right sample. Next question. When will be available Hydrovax Experimental 004? So good question. This was a product that we manage in a sample scale, so in a lab scale. In the next 6 months, we are ready to start an implementation process. It so means that you can ask a sample. I think that the time is running. I will read you another question. Can you explain better the primary particle size of the emulsion? Are really emulsion or dispersion? No. Good question again. Good technical question. No, I want the Hydrovax 5080 and all the free Hydrovax. So the Hydrovax 5080, Hydrovax 5028, and also the experimental product are emulsion, and are emulsion that as a primary particles depend of the emulsion, of course, but are all emulsion based on primary particle size below 1 micron. So we are in the range of the nanometers. So if the purpose of the question was to underline the difference from dispersion, no, are not dispersion, are really emulsion. Next question, and I want to underline to you that we will produce this product in Germany, in our facility. All the free products in our facility in Germany. We have a reactor in Sasol, Germany, in Marl, and reactor here in Hamburg. So without problem on capacity and on sample request. I think that I finished for now all the questions. Again, I promise to you to reply to all the dedicated questions that you ask, and you will receive an email in the next 2 weeks from me or from our team, IPC team, with the presentation that I showed to you today. And you will see this recorded section in the next 2 or 3 weeks on our Sasol page on YouTube. Thank you very much for today and for all the participants that were from all the globe. And thank you. And I suggest to you to follow also the next webinar, the inks one that will come in the future. Thank you. Bye-bye.